Okay, so I guess now these things are settled for everyone. And I see that you have laptops, most of you. That's good. First of all, welcome to the workshop of iLand. Well, iLand comes from the individual-based forest landscape and disturbance model. It's more than this, but I mean, only this stage. Before starting, let's see if you have the files that I sent you. Everyone has them? I sent an email last evening with a link and then also some information about R.
Most of the people have it, but some of the people are just watching.
Yeah, I understand, but if there were some technical problems to do them now, not before, after we can you open the file and see if you have these files? Everyone, yes. Okay. And with R, you have the packages. We will install them, but it's easier if you already have them. Yes, silence is a reply. Okay, then just a structure of the workshop. First, I will give you an introduction about what iLand is, but it's not in detail. iLand has lots of formulas because it's a process-based model. We will not go through them. I will mostly focus on how to apply it because we will be users and also some people will be developers, but most of us users. I'm a user. And after this brief introduction, I will also give you more detail about spruce-bark beetle module, because this is the meeting in RESDiNET about spruce-bark beetle, so we will have more insight about this one. And then we will go to input data, output data, and then check the project file where, in fact, we say to iLand what to do. And then we will do some simulations, some very brief data analysis, and that. Okay, first of all, is my voice clear enough for everyone? Should I talk louder?
What about those online?
Yeah.
Can you check?
Can you hear my voice online?
Can you ask by the chat?
Yeah, someone is showing.
Yeah, there you go. Thumbs up. Okay. Okay, so then we can start with the iLand introduction. Okay, as I mentioned before, iLand is a process-based model that was built to simulate interactions between forest dynamics, climate change, disturbances, and management. It was developed gradually. It started, well, the first publication was in 2012. It started to be developed in 2008, around that. And then step by step, different modules were added in iLand. The program itself is coded in C++. So if someone wants to read it, how should I say? If someone wants to do that, to understand the coding. How do I hear? In this one? Ah, yeah. Comes from here.
Yeah, that's fine.
Yeah. Okay. Then you mute your computer.
If I mute my computer, yeah. Okay.
If you exit, it's like,
Yeah, there's a microphone.
oh, well, how do I, like, I want to, like, the volume.
We have to stop sharing.
Yeah, from there, if you mute it. Yes. Okay.
Okay, then let's share it again. What we need to know from the beginning is that iLand is complex. So the processes take place on different scales. Is at 3 scale, some processes like growth, mortality, and then there is the 10 scale like production, growth, primary production, some other that primary production, radiation, and then at landscape level we have the disturbances and so on. The code is open source, so everyone can download it, even the code for as a user, but also as someone that wants to make changes. Everything is available. And also as far as I saw, the developers are happy to see that iLand is continuously improved. Yeah, the processes, again, going back to something more clear, the processes in iLand are continuous and discontinuous. Those continuous are activated during the whole simulation period, and then the discontinuous are either triggered, like the module is triggered by other events, or triggered by user, like management. User can say when the management should happen. The continuous processes here, again, the regeneration, growth, mortality, and then they have different phases, each one. The discontinuous processes, as I said, the disturbances. The disturbances include our fire, wind, and bark beetle, and some general biotic disturbances. And also in this discontinuous is the management. Well, yeah, for this meeting, as I said, we will focus on its typographos module, and I will show you some how equations are implemented and what's implemented in the Stuttgart Beetle cycle. As I said before, iLand has started to be used in 2012, and since then it was increasingly used, and nowadays are over 50 papers published. Most of them are in Central Europe, but there are some in Northern America and one in Japan. And well, in Northern Europe also, they start to be developed, even one. We are some of those who start using it. But in Finland has been used in already one paper. So talking about complexity, there were many topics that were approached so far. Most of them were about ecosystem dynamics, and others about changing carbon, ecosystem services, timber. But for most of them, the trigger of change was disturbance or climate change or management or some sort of combination of this. Yeah, that was my big picture about iLand. I hope I could have managed to to put you on the map what iLand is. By the way, do you know what the process-based model is? Have you worked with it? In principle, the process-based models are a collection, let's say, of equations that would run one after each other and simulate or imitate the processes in nature. Just, like my own definition. But this is what iLand does. So has really a lot of equation, and at the end it brings different out. Okay, information about iLand are many. They have their webpage where, let's go there. This is, if you want to use it for future, it's good to know where to look for information. And in this iLand model page, in wiki part, they offer all the description about the model, but how to initiate, how to make a landscape, and then what's the project file, what are the outputs, and so on. They try to describe it as comprehensive as possible. Then still in this page, you can find this Discord, which is a platform where the scientists are actively writing either about their problem, so they can ask, oh, I'm trying to do this and I found this problem. And even developers would go and answer the questions if they know. So people know that isn't that easy, and they try to support each other. Okay. So for example, there is a forum where people say something. Yeah. And people ask questions. That's all. So even if it's hard, you're not alone. That's what they want to say. Why does it go so hard? Is it because I'm on Zoom? There is also an iLand book where you can find details and some examples, again, how to start using it, but also how to change in the script and to make scripts for different models. In my opinion, some information is easier to understand for programmers than for foresters, but at the end, yeah, you'll get it. And the list of publications, and if you want to download it, is here, Get iLand. Okay, let's do the presentation. And here, yeah, this paper, if you want to see some general information about iLand, this is more like what has happened in first 12 years of since the application of iLand started. And yeah, this is quite clearly written. So if you want to start with iLand, that's a good paper to start with. And here is a nice tool, is an AI tool where you can ask questions about iLand. What or how is this implemented in iLand? I don't know, let's say, how is Beetle implemented in iLand? And you get information. Or even for code, well, you bring some code in there and ask what is it doing, and it will explain what it is doing. So that's also good support for.
Just question, this is connected with ChatGPT or?
Well, they have an internal database where they have all the publications and the iLand book that I showed you, so they have more is intern. But it's like ChatGPT, you ask questions and it will provide you answers.
It is intuitive, yes?
It is, yes. I mean, let's ask a question if you want.
Yes.
Okay, what is iLand? It takes some time. No. This is an excellent question. And then it gives type of model, process, based purpose, core philosophy, and so on.
Thanks.
Yeah. So as you said, the RESDiNET is a complicated model, but they try to bring some support tools for users to make it easier or more comprehensive.
My team wanted to start working iLand in maybe 2010 or 12, but we had we failed.
Okay.
And now we hope there is some development and we will understand it and maybe.
Yeah, but since then they improved, and of course they develop also, but also they improve the information. That okay. Yeah, and it is in a continuous development.
It's like the whole specification.
Yes.
What is the page quality of this AI plan?
I will send this also. Yeah. Is there a chat so I can even send it in the chat? But in the break, I can do this. And I can give you the presentation. And I have links in the presentation.
Maybe we need to get an account, yeah, because we're not now logged in. Maybe that we want to see that.
No, but I can send it on email. I can send the presentation on email. Yeah. Okay, so now if you have questions about iLand in general, you can ask now or later, whenever. But otherwise, we'll go further to talk about Spruce Beetle module. Yeah? Yeah.
I have some question about what are the limits of this tool, because you say it's process-based model, so it's based on some correlation, maybe also some allometric, I suppose, equation or something like this. But why do you know where these equations are valid or are not valid? Because each equation it has a limit, of value where it can be used, and if it gets in other values, you cannot use them. So
Yes. Well, it's best to go in the code and see what values are used.
Yeah.
But it's also documented in their first paper, in that one from 2012 for the growth module. And each module has a paper that was published somewhere. Yeah. But the best is to go in the code and inside the code and get the creations and see. But some are pretty general, for example, for light availability index, that's, I think, is commonly valid, or for radiation or so on. So these are things that are common. But then the problem that I found, and we will talk about this even later, is that spruce bark beetle module, some things are easy to change in the parameter file, but some things are, let's say, in the black box of iLand. So you need to have some programming skills to do those changes.
Question, you showed that, for example, tree mortality is on the tree level.
Yeah.
Is it possible to upscale it to landscape?
Well, yeah, this depends on your output. If you take the output at landscape level, then you will get the reasons why the trees have, we also have it, the reasons and the years why they have died. But the initial information comes from the single tree, and then iLand calculates the scale. Or also you can have this information at the stand level. So that's what you say in the output. I want this, so they will give you that.
So that depends on what kind of data you input. And if you have a small resolution data on the tree level, you cannot always upscale it to the landscape level. But if you have on the landscape level information, it's not possible to do that.
Not really, because the input data is standard. So you always have to give a certain resolution for the data. And then iLand will, for the individual trees, you don't give coordinates. We will go to this, and maybe it will be more clear about in the input data. But it's all about the input and output in like every model. Okay, so then bark beetle module was first published and started to be implemented from 2017, so a few years after the initial publications. And an outbreak in iLand is triggered either by a wind damage or is a climate sensitivity background, which is mostly related to drought. It is the probability of infestation, infestation to happen in one cell, and which is modified by a climate sensitive factor that is something related to precipitation from the previous year, so drought. These are the only triggers. And then once the outbreak is triggered, then for every year, iLand will calculate every step of, let's say, bark beetle development, is the dispersal, and then goes with the colonization, development, and in the end, overwintering. Then it also calculates if there is a sister generation, if there is second or third generation. These are based on some climatic information that I will show you next slide. Yeah, the dispersal is in a random direction, but there is a kernel function that calculates the probability for one cell to be colonized, and then it decreases with distance the probability. It's a kernel function. And then for colonization, if let's say then there is high probability for a cell to be infested, then it evaluates if there are spruce trees with diameter bigger than 50 centimeters, and then it evaluates if those spruce trees are vulnerable or they can be stressed by drought, or they can be wind-felled. These are, and they need one cohort. I was saying what that means, one cohort to be killed. And then if there are healthy trees, and there are no other infested trees, they will infest the healthy ones, but then they will need 6.7 more cohorts to kill the tree. One cohort is the number of beetles needed to kill one tree, one stress tree. So that's one cohort considered. For the spruce, for the development cycle, this is what happens behind the bark. Is taken this Finnish model. Maybe you've heard of it, some of you, is this Bayer in 2007. Well, I have a better slide for this. And this one takes into consideration the climatic conditions for spruce bark beetle to do every step. So the Finnish model calculates the day of the year when the onset of infestation happens, and for this it evaluates the air temperature that should be more than 16.5 and the temperature sum that should be more than 140. This is what they found when we developed the model. And then to calculate the sister brood generation, second and third generation, there is a new coefficient, T sum, which is calculated based on the temperature of the bark, temperature sums of the temperature of the bark, and the total development cycle of one generation of bark beetles. And if it's 0.5, this one and the other condition, the air temperature and the day length, are fulfilled, then there is a sister brood generation. And then if the T sum is more than 1, then it calculates the day of the year of the second generation. And if the conditions are not fulfilled, then the beetles will go to overwinter, to sleep. Only the mature ones. So in the overwinter, only the mature one will overwinter. The ones that have not reached maturity will be removed from the system, so will die. And then this cycle repeats every year until the collapse of the outbreak. At the moment, the collapse of the outbreak is defined by the user, and what has been tried so far is 5 to 6 years. I also have papers that say this. And then the infestation have a negative response, so they will decrease with every year. Yeah, and if there is salvage cutting, I have here, implemented before they start flying, then those trees will be removed from the system and there will be no beetles starting dispersal and other generations. So yeah, that's also implemented. Is that somehow clear? Okay, then.
I think all is clear and we are doing it very nice.
No, but if you have questions.
But I understand it, but I'm not sure about others.
How does a cohort estimate the number of beetles needed to kill one stressed tree?
Well,
I think it's like depends on the tree size, but also how is the stress measured? It's just some mean on the field measurements.
Well, now it's not really a number. They just consider a stress tree the reference. And then if that stress tree can be killed, then they will just, because you have a number of cohorts. So if one cohort killed one tree, the cohort would be removed. And the tree, is damaged, is considered damage. And then if the tree is healthy, then we'll take the reference that of a killed tree and multiply it by 6.7 and remove this many cohorts from the system.
You mean that cohort is just one cohort equals one killed tree?
Well,
yes or no? Because
no. It would be, so you have the tree, and then you have one cohort that would kill the infested tree, and then you have the stress tree, and then here you have a healthy tree, and then you have 6 times more cohorts that would kill this tree. And then I have one, let's say I have one stress tree and I have one healthy tree. So then I have one cohort that kills one and 6 cohorts that kills one healthy. So then from the systems are those 7 cohorts that are considered.
Just the variable that is introduced as a proxy of the proximity to previously colonized tree to model the next infestations.
Yes, well.
The number of
No, it's not. Yeah, you don't have number of, because you just have number of cohorts. Yeah. iLand has, as well, I mentioned a little bit before, so has a black box where some parameters are defined. These are not user friendly, but then there is a parameter file where things can be changed. This information with temperature and day length and so on is in the black box, so you cannot change it at this moment in iLand. But then there is a parameter file where there are other parameters that can be changed, and they have been changed to do some sensitivity analysis. What I'm presenting here is what's the, let's say, the default value in the first paper published, what they have used in the first paper. And these have been used in next papers after, so really small changes have been done. Yeah.
What is the predictive power of this model?
Sorry?
What is the predictive power of this model? Was it test in some real setting, some case studies in order to predict where the outbreak can happen, or?
Yeah, in the first paper they had some validation also, but I don't remember the exact number and really the power. Because it's a process based, it's not that easy to say it. It's also, but yeah, it was statistically viable. So yeah,
Okay.
that's why they publish it.
Yeah, that's why I also.
Yeah, we did this, but I will show you tomorrow
Yeah,
about. But this is with our data, not with
because
the initial.
there's always a question with this process-based model is are there tools that we are using in order to better understand mechanisms, or are there tools that can really predict some things? Yes. Yeah.
Well, in this case, it's more to predict, but you cannot predict 100%. So
yeah,
just to make an idea what could happen if.
But I think that this is maybe very opposite. It's a good model to understand mechanism because it's process based. And,
yeah.
I think the processes are there very well described, and I think I just done some study maybe 10 years ago. I wanted to find the best model for modeling by beetles, and this was the best one.
I also think it's a good one because it considers all those steps of, so it's complexity. So you have the dispersed, the colonization, development, and overwintering. Also, then the trigger of the outbreak. So it's all the cycle that is repeating. I guess in this sense, it's good. It's not only based on the probability of some of this to happen, but there can be many opinions. And of course, all the equations are from literature, so they didn't just think about something and just put it there. So it's everything based on science. In that table, I also put the references where they took the information from. So, well, if you feel like checking, but if not, it's okay. And yeah, every part of iLand has, because it's so many equations, you find them where they took them, so they have this information. Even in the code, they say in the code that it comes from this. Okay, I was telling you about this project file where you can do some changes. Yeah, the only changes that you cannot do currently is related to temperatures and these weather conditions for spread beetle development, but all the others are now user-friendly. Is first, to initiate the outbreak, it needs this initial infestation probability, which, well, actually is not to initiate the outbreak. This is saying, okay, there is a probability that in this cell was an infestation before it started. So it's just but it's very small. And then this background infestation probability and the climate sensitivity formula is just that I said about drought, the one that this is how they calculate. this climate sensitive background. They use those two parameters. Show it from here. Yeah. This one and this one, they show the background probability. And then this is the storm infestation probability is the probability that one tree is killed, but one windfall tree is killed by spruce bark beetle. And this comes from some empirical studies. Then the minimum diameter for trees to be colonized is now 15, but it can be changed. The kernel formula that I told you that is the probability that beetles spread to some certain distance from the originating cell. And this formula is evaluated until 257 meters. It's just what the other people said. Generation cohorts per generation, and these are is the reproduction rate of the beetles, the number of beetles spreading from infested pixel from each generation. So generation is 20, and then if there is a sister group generation, they would add 10 more cohorts per cell. And the cell in spruce bark beetle module is 10-meter resolution. The colonized probability is this one, which evaluates the stress index, so they know how many cohorts they need for one tree to be killed. And then it continues with the winter mortality. In the winter mortality, there is a base winter mortality, so not all the beetles survive. Some maybe they have something with their digestive system or whatever, so they don't survive. But it's also this winter mortality formula that is it's calculated based on number of days with temperatures lower than -15. And then the last ones are the duration of the outbreak that I said that is defined by the user. Yeah, those are in project file, and they have done, maybe I don't know if it helps with your question, but they have done some sensitivity testing to see which of the parameters from the project file are more sensitive if they are changed by the user. And they saw that cohorts per generation is the most sensitive one. So if they change the cohorts per generation with plus 20%, it would give 73% more infestations. Yeah, the changes was plus -20 for each of these parameters, those 5 parameters. Plus 20 is high and -20 is low in the graph. Well, just to have an idea. So some parameters can be sensitive to changes. And because of this, we always have to have a reason to change them. So that's a little bit tricky when we work with iLand. Well, and with the Beetle model. Okay. We are getting close to the input data, but before that, in iLand, there is a viewer where you add the input data as project file, and then you run the simulations. The iLand will make an SQL database output, which then will be evaluated with R, Python, or whatever is needed, but the output is SQLite database. I will show you this. What is funny, and Katharina made this graph from below, the most demanding to iLand is to prepare the input data, and it is so, and also Rastislav has mentioned this. And then, well, evaluating, then running simulation is really short, easy. Well, it's now depending on how big the landscape is, and then analyzing the result. We will see this in the next phases. Okay, so input data, now that we are getting close to doing something. See some people sleep, but that's okay. Do you need some coffee?
Bill, coffee at 3 o'clock.
Okay.
To make physical drift more active.
Yeah. Do you need some bucket of cold? Okay. The input data, which there are just a few files that are crucially important to have, is the parameterized tree species. The file is already there. The species have been parameterized. It's always good to check it to see if you have the species that you have in the forest. Check them through, see this later. And then we have the climate file, is a database file, escalated, and it needs information, daily information for minimum temperature, maximum temperature, precipitation, radiation, and vapor pressure deficit. Okay, so then we have information about environment. This one has two types of files. It has a raster file, which is in ASCII, and it needs a grid. It's at a grid of 100-meter resolution, and each grid has the value of the number of the stand. And then there is text or SCV file, CSV file, and there you add information about the climate table from that. Okay, I will show you here. So in the environment file, we have the grid and the file. In the file, we have the climate table, which is in climate database. You just have to write the name of the table that is here. And then information about the site, the soil here, the nitrogen availability, soil depth, percentage of sand, silt, and clay. So these are compulsory to have. Then there are some other information about environment, but iLand works without them, and it will estimate them from other parameters. We will check this file after I present the input data. So now we have the species, the climate, the environment. We need to have also the location of, so the projected coordinates for the first cell in the left bottom, first cell from the left bottom corner. You just need the X and Y as a location. And then for the stand, we also need the 2 to 5 stand grid, and which is a 10-meter resolution. And then the stand file, which is text or CSV, that has the stand ID, and then the ID is found in the stand grid. The number of trees per hectare, the species number of trees per hectare, DBH from DBH2, the relation between height and diameter, and age. Species are usually defined here as Picha abies, P, Picha, AB, abies, Fagus sylvatica, FA, SY. So these are all the species based on the Latin name. So these are those 5 are the most crucial files. Yes.
What was the HD?
It's the relation between height and diameter. As slenderness index, probably it's more.
Yeah, I just didn't hear it.
Yeah.
Okay.
And well, there are some optional files depending on what you want from iLand. In this example, because we will implement management, we need manage a file about management, and then we want to print the map from wind and to vertical disturbances. So we need an extra file. We will go through that. Yeah.
So like for the DBH, for example, you have like the range, but for the HD and the age no. So do you then like is this like an average, and then in the model they randomly attribute like each tree within an SD?
Yeah. So you have you give this information to iLand, and it will automatically calculate the attributes for each tree. You have a cell, and then it will make random trees that will fulfill those conditions. But yeah, you don't
with randomness.
Yeah, it's random. You just have the number of the trees, and then you give this range, and then you have you can add also individual data, but you can imagine for thousands of hectares, that would be too much, even for a user to create all this data. So then iLand would create them. Because especially, I don't know if I mentioned, but especially explicit. Yeah, so this. Let's go and see them now that this information is fresh. Open each file. So the species and the climate are in SQLite database, so we have to open the database first. This for species. Can you see from there?
No.
I'm not sure if I can make it bigger from.
I don't know if you can zoom this.
The thing.
Yeah, but then the whole screen doesn't fit, but at least the R would fit maybe.
But anyways, that's enough.
So
Okay. Can I read it? In R studio. Sorry.
Yeah, you can. You need to zoom in.
To make the size. Okay. Good. Yeah. So the species are this short name that I showed you also in the table before with Pinus sylvestris, PISI, Pinus sylvestris, and then they have many parameters that are used in every module they need. Honestly, that's the thing of the developers, and we just need to check in the list if we have the species that are in our composition. But there are 30 species: Obina salis, Tilia populus, Acer, Quercus, Alnus, Facpinus, Fraxinus, Spicia, Habeas alba, and so on. So they have the main species from Europe. I don't know how they use it in Japan, but they know it.
Can this model work with a mixed stand also?
Yeah. In the stand file, you have the number of the stand. You say, let's say this is stand 1, and you have species Pinus sylvestris or whatever you have. And you have this number of species, the count, and then you give all the other information. So next row, stand 1, species, I don't know, like the chihuahua, they cannot be the same, but then you have all this information.
So one line, one species in one stand.
Yeah, exactly. Okay, that was the species file. Basically, you should only check if you have the species. That's important here. Then for the climate file, the one that I have here starts in 2015 and goes until 1095, goes until 2099. It's really long, also with some projections. And you have the month, the day, the minimum max temperature, precipitation, radiation, and vapor pressure deficit. These are taken from the weather stations and so on.
And could you tell us where to get this data in general? You have to have data from meteo station.
Well, it's good to have data from meteo station, but it can also be downscaled. But then it means that that's more complicated, in fact, because you need a table for each area of your. That's well, I can use this.
Is that I one point, because like when we have mountains, like
Well, let's say that this is our landscape. Well, it can be whichever shape. And these are different climatic zones. So we have here mountain and so on. And for each one, and we have here stands, different stands. If this is one climatic zone, we need to have one climate file that contains all this information. And then in the environmental file, we have here the stand. And 1, 2, 3. And we say stand 1 has this, has climate 1. And then if we have here other stand, well, they are not really this shape. We have 101, 100, 200, whatever name. And this is climate file 2. And then for distance, you would assess this climate file. And all the climate, every climate zone needs to have their own data. Yes.
this is very hard to do. And
Yeah.
are you apply this for Finland or for some part of Finland? Or?
Depending how big the landscape is. For my landscape wasn't that big and the variation in temperature wasn't that high. So I just use the same climate file for everything.
This model is developing in Alps and in mountains, and how they solve it in mountains.
Yeah, then you have to make some climate zones that you decide. So the upper part of the mountain is a one climate zone, and then middle part other climate zone. You cannot make it really, exact in that point what was the temperature.
Okay, and I think that this climate data are good. I think when you want to do it perfect, it is very hard work to make climate in mountains.
Yeah, well, it is, but you also have to make some assumptions. If the differences are not that big, then.
Okay.
But of course, you cannot live at the top of the mountain the same climate file as you have at the bottom of the mountain.
And what about this future climate? You use some climate models, which are somehow in the databases.
Yeah, well, these are also the climate models that exist in the meteo station of database. At least in Finland, you can download projections for some climate.
In Finland, can have projections for maybe
Yeah.
100.
And there is a new tool now in iLand, well, new for me at least, that you can make projections, climate projections, and say RCP 2.8, and then it calculates automatically the projection based on the factors that are known from the IFE from the reports. So,
Okay, there is two for this climate, the different climate scenarios.
yeah, for climate change, yes, you can do this, but you first need the information for the climate, and then the climate data is recalculated by iLand based on those factors.
Oh, okay, thanks.
It's
I think this is quite a big challenge, but I think that
Yeah, I mean, you saw that the biggest challenge is to prepare the landscape and the data. That's not impossible. Okay. And what I'm showing you here is climate 1, so which means the table 1 from the climate, but there are more. There are, let's see how many. So there are 99 climate zones. But this is for the whole, well, I will show later. The landscape is big, I didn't use everything on that landscape. But yeah, this is a bit of work. And then the environmental file, this is what So here is, say, the climate table that I showed earlier, the 100. Well, it's somewhere here. Yeah, climate 100 is linked to this stand 801 or 8127 stand. And then there is the available nitrogen, soil depth, sand percentage, silt and clay, and the other information as well that you can give for different models. But anyways, they are not compulsory. They are described in Wiki in that page, so if someone wants to check them. And here's the raster, but there's not much to see. It is 100-meter cells.
Where did you get this environmental data?
For this one?
Yeah.
Well, I have the landscape from Katharina, and she, yeah.
Okay, but in general,
But
you just
for the landscape I did from Finland, I have some information about the soil from Lukia,
okay.
and this is based on the site type. Site type and species composition.
Okay, yeah.
So, yeah,
So you just have to find it somewhere.
yeah, everything you just need to find the source for the data. But nowadays the data collection is getting better, with remote sense and open source and all this. So okay, the stand file. So here also we have a grid, but I'm not going to show it. And then this has the stand ID, the species. So this one, can you see it? We have Pinus sylvestri, we have Pinus abies, different ages, different compositions. So that's mixed stand, really mixed for one. And all the information there. And then there's also a sapling file. It's not compulsory, but if it's not bad to be there. Where are the trees that have a height smaller than 4 meters in each stand ID? So these stands are not going to be evaluated for, let's say, for spruce by beetle. They will just be removed. They will not check if they are more than 10 or 15 centimeters in diameter. So it's easier for iLand. Okay, how is it? Complicated or more clear?
I think this is complicated and
Yeah.
it is very hard to make this simulation.
And yeah.
And I just think I missed, where did they have the project file that they had in the beginning to generate this?
Yeah, I wish that's the next step.
Okay.
We'll go there. Well, then I will tell you about the output when we talk about project file. But the outputs are, well, let's say no. The outputs are many. We have, so here, a long list of outputs. You just need to go to iLand page, that wiki, and see which one is suitable for your study. If you want at tree level, at landscape level, if you want output about carbon, about disturbances. So depending on what your research question is, you go and look for the output. There are many. But the output name has to be defined in project file that we will see now. Okay, let's go to project file. Is someone online? Now that we know which are the input data and we already have them available, then we can see how we implement them in project file and then how we start simulations. So you also have these files and you have everything available that I'm going to show you now. On the right, I have the project file, and in the left, we have the file, the folders where the files are and how we should put them in project file as the input. Okay, so first input that we have is in this database section, where is the species, and we find it in folder in database. So in database, here is the species folder, and here is also the species, the name of this, the file. So this folder again, the information from this folder needs to contain the project files, which are these XML files, and different folders where the input data is. Because then iLand knows where it has to look to read the files that you define in the project file. This is how they are connected. Okay, in database from project file and in database from the file, we find the species and the species here too, and the climate file. The climate file is this one, and here is also the climate file. Yeah.
Right.
From what? I didn't understand, sorry.
The right side of the window, where did you get it from?
Yeah, well, this is on the webpage. So if you look for a project file example, you can even download it
On
from
which webpage?
wiki that I showed you earlier.
How should we have this, what you had on the right side?
So the idea is if you have your landscape and you just use the structure that I gave you here and you just put your files, you already have it. You have your files instead of mine, well, mine, and the project file that suits to your need.
But right now, the file that is open here is Austrian APL salvage.xml. Right?
Yeah, this is the file that I opened as
And
an
it's
example.
the iLand census file.
Oh. I mean, where you find it right now.
Oh, yeah, okay, yeah, now I
Right,
found it.
page now.
Okay, sorry. If you want for this exercise, you go in your downloads. But we will do this together later if I'm just showing you. But yeah, if you just for clarity. In the files I send you is the iLand exercise, which has the files where all the input data is and the project files are under. And then there is another file, iLand viewer, where we can find this viewer exit, we'll open later, and run the simulations.
Do I need to run the applications, but my computer it prohibits running these applications.
Yeah, I will show you how to open it. Can I see now that we are?
But I think it's whatever from that. Yeah, if you just go. Probably more people will find it. I mean, if you're curious, you go like this and go to properties. Yeah. Thank you so much.
But we will go to this together later, so just pay attention to project file. All right, so first now we decided, do we have the species? We decided we input the climate, and now we do the environmental data. Environmental data is in a model section, and then you just have to search for them. The B word in this section, and here we have the grid, and here we find it in GIS. In the folder we go in GIS, it also shows here. GIS, we go to the folder, GIS. And then first we have the grid, VB object ID, VB object ID is the same name, it should work. Then we have the text file, where we have that climate information, then the soil information. Here is environment VB new is here. So the files have to be placed in some specific places. Otherwise, you have to provide the whole path for iLand to know where to take it from. Next would be the coordinates of the left corner is in locations. Well, these are the coordinates. You just have to take them from ArcGIS or whatever map program you use. And then the last one, we have the stand information that is it can be found in init in the file, and in project file is stand grid separate than the text file or SCS. With GIS it shows GIS and stand ID raster. This is there. This is there here. And the file, the species file is in initialization, which the file is init. So we have the file, the trees is here and here. Well, this is how you basically input data in iLand.
And I just asked, I was lost at this corner in which system you get this coordinate?
Projective coordinate system.
But which projection?
Well, depending on your map.
Okay, but they don't use some like coordinate system. They use local.
Yeah, it's the local one, exactly. You just go.
And do you have polygons of the stands?
You have the grid that you have to input. So the environment and stand data has a text file and a grid.
But stand in GIS, there are mostly polygons.
Yeah, exactly. And you have to convert that polygon into raster, and each cell would take the number of the stand. And then for environment, you need 100-meter grid, and for the stand, you need 10-meter grid. So you have your shapefile. You convert your shapefile to raster. And raster has a different resolution based if it's environment or is a stand file, raster.
So what attribute will be given to
The stand ID.
stand ID?
Yeah, both of them need to have, every cell needs to have the number of the stand.
But this is quite complicated. How we do it?
How you do it? Well, you just convert it in, if you RGS, I use it RGS and I converted it. And then I didn't mention, and I should have, those maps, rasters are saved in ASCII. So it's ASCII, yes, format, not raster or TIFF or whatever.
Okay, in my language, that is, iLand is doing all calculation in some kind of grid in cells.
Well, to initiate the landscape, yes.
But is all these grid cells, and there is some do have some process line how to make this stand data, like because I think normally you map with polygons.
Yeah, you have the map with polygons, which is a shapefile, and then you convert the shapefile to raster, having the grid cell, and the value of the grid cell is the number of the stand, and then you convert you convert the raster in ASC, the essential, and then you take this one and you bring it to iLand.
And this procedure is somewhere it is described, yes.
I mean, it's not complicated. It's just converting.
We will try and we'll see. Okay, I understand.
Sorry?
It's simple.
Yeah.
It's simple. Okay. Because I coordinator today don't have to do it, but maybe Bashir will have to do it.
Okay.
So don't sleep.
My question is this, so we have a 10 into 10 meter or pixels, so it's plots, right? It's not a stand. Because
Well,
that means it's considered as a forest stand. So
yeah, it's a forest stand. So you have the number of the forest stand in that cell.
So if you have 10 into 10 meter plots, so we will have multiple pixels
With the same number,
stand.
exactly.
Okay.
So then at the end,
Well, define these, okay, these stand details goes to this point.
well, you have the map in.
So we are giving an average of the stand data we are giving as a input parameter for the individual.
For the stand, you mean?
plots. Like for the each pixels, you are giving some input data.
You don't give input data for pixels, you give input data for stand.
Okay.
And then iLand would put data in the grid cells based on your whole stand.
How we will identify, because in the one stand, there will be different density of trees or distribution.
You have to say it in the stand file.
which
You
may-
say the number of trees.
It's all the stand. It's for the stand, right?
Yes, it's for the whole stand, yes. And then it's the number of trees per hectare. So 1 hectare is 100 cell. And well, iLand just calculates everything there.
So it's like it's calculated for the whole stand.
Yeah.
Not for the.
Yeah. Well, the grid is there because it's specially explicit. And then the information, the trees are randomly placed based on the text information that you give, the number of trees and the diameters and.
For example, we are giving in one stand there are multiple species. So how the model will identify that this species is located in this particular region of the stand?
It will know.
If
It will know the stand, but not really the exact place of the stand. So that's a random.
For example, sometimes it is mixed, or sometimes it's like clustered in some region.
Yeah, you cannot define the type of mixture here, or at least I don't know to be possible to define this. So you give this information, and then iLand randomly distributes the individual trees in that stand. That is.
I had a question, since like we work at landscape level and the landscapes are not only forests, like if you want to have like, it's not maybe a stand, but if it's a classification that would be just like grasslands, is there like a code for species for this?
That's one of the limitations that even developers have mentioned, that iLand doesn't recognize other type of uses, only forest. So if you have in your landscape a building, it would just be an empty space. But at the moment, there are no interactions between other uses. So if it's a meadow or whatever else. But I think if they recognize that that's a limitation, they will try to develop it for future.
And there is no way like to do this by just then setting like a species and then just put I know you don't have a parameter for how, but you can.
It's only you can is optional, but you can add lighter information about canopy. You can add it, but anyways, you have the height and diameter relation, and it will be calculated from there, but only for the trees, not other.
So just one question to know if I understood well. iLand is a process-based model.
Forest landscape.
Forest landscapes, but it's also modelized the tree individually inside the plot, despite the fact that you are not giving the individual position of each tree.
Yeah, I mean, they are randomly distributed, and the best is to evaluate data based on at stand level, not at individual level. But they make individual trees for mortality and some other processes that are happening at individual trees.
Just a comment that this sort of data is usually what the forester said, that you have a polygon, like the Polish forest fence, but in GIS it's a polygon. And usually not just the district, the percentage of different species, but the forestry data never tell if smooth is on the left, on the first and on the right. So you tell only the percentage of the distribution. I think that's why iLand is working like this, because in Central Europe, this data is the most precise from forest.
Not to make it more complicated than already is.
10 minutes before the coffee.
Okay, so then we will finish looking the project file before the coffee, and then we will have the break, and then we will run one simulation together, and then we can work individually something. But just for the project file, we have seen where the species climate data is, where the environmental data, the grid and the text file. We saw where the species data is, again, grid and text file, and the coordinates of the left corner. What I wanted to show you is we also use in this example, and it's useful to use in other examples as well. That's optional, but it's good to have, is implementation of management if there's an interest, and how to print maps. We will print maps for wind disturbed and spruce by beetle disturbed areas. The management, that's also something new for me. It's not new for them, but new for me. So for the example that we have in the management, in the project file, there is a management section, and we have first to enable this because it's an agent-based engine, and you have to say it true. And then there are two files. We will go to see the files. One is a JavaScript file where you define all the management options and the stand. Well, something about stand, and then the stand, and in each stand, what type of management is applied is then defined through a CSV file. Well, this with management, what I implemented here is only salvage, but it can be a full program of managed options. Now, in the file, if you go to ABE, we have the JavaScript file. I will open it, but I cannot really explain it entirely. Is Katharina here in my meeting? Let's see. No, she's not, but I will tell you whatever I know. And okay, so this JavaScript file defines every type of operation that is done. Is clear cut, thinnings, different thinnings, planting, regeneration cutting, salvage cutting. For this example, I only left active the salvage cutting, and this would be activated when the this tree is more than 5 centimeters, and the stand is more than 50% disturbed. This can be changed here. And then there are some other things that you have to set in this management files related to species composition. This is the rotation age and so on, but I cannot explain you really everything in this one. But anyways, for this example, we use the salvage logging. Okay, this file goes here. It's in the file in the files, and then is in project file also. And then in the stand, we have every stand, and here's one. This one tells that in only salvage cutting has to be applied, which is linked to the JavaScript file. This one. And this one is only for salvage operations. That's basically, but it's for me, it's hard to explain it because I don't fully understand it either. It's now for the example, we will use it as it is. But also, I mean, if you want to use it for future like this, you can use it. Okay, and then this one is for the management, and in the management part, because we have the salvage, in the very bottom of the page there are some things that are defined by the user, which says how much of the stand has to be removed if more than 50% of the stand is damaged. Here I just put 95%, and if we want trap trees, and 25% of the trees can be used as trap trees for bar beetles. Okay, then to print the maps is at the beginning of the project file in JavaScript. And we have in all this folder in scripts. And this map, wind, bar beetle and wind, this one is salvage. And then for the non-management one, we will use this one. So if you want to see. And this one will print a map every 10 years every 10 years of the simulation, year 10, 20, 30, and until 100, if we simulate 100 years. But this also can be changed. Well, these are more confusing because it's programming. I'm not there yet. Yeah, I think that's it about project file, how to put the input data. And then we will see how to start simulations. And then you will have to do by your own son or whoever wants to do it. And then we will do some data analysis in R. That's it. But if you have questions.
So did we have to make all this modification then in the file, or the file are already okay for running the?
They are okay for running the.
Okay.
Yeah, it's just to get familiarized with the files. Yeah. What I'm showing you is what in those folders that you copied. And it's also, well, maybe I shouldn't, but so if someone doesn't want to run the iLand, I already have some outputs here that we can just use.
But to create such file ourselves, it's you just like create first a folder with like the same structure as you mentioned, and then like the SQL file is created directly.
Yes, exactly. Yeah, you mean the output?
Yeah.
Yeah, so you have the project file, and then after the break, we will see how to run simulations in iLand viewer. And then after the simulation is done, then iLand creates the database for output. And there are the outputs that you decided, I can show you this. Yeah.
So, but I mean, like this question has salvage XML file, like you didn't create it.
I didn't do it myself. No, I have it from Katharina. From
even
a friend.
she didn't like wrote it.
I don't know.
And then if you need, for example,
this was part of a study that has already been published.
Okay.
I will show you after then the study and so on. I didn't show you the output now that she mentioned. Okay, the output, what we want to iLand to print is also set by the user, and there's a section in project file called output. And here you have all the options for outputs. If it's false, it means that you don't want it, and if it's true, it means that you want it. As I mentioned, you can check the possible outputs in iLand webpage. output. So, for example, we will use now for output, we will use stand output, the removed trees, bark beetle, and wind output. If we go to the stand output, here's the stand output, and it describes output of aggregates on the level of research units per species. And well, it says all the details, and then you have the variables in the output table. And this is for every output. You just need to know what you want and how you can get it from iLand. That's the user part. There are many. And what we have here active, we set true for stand, the one that we just saw. And then we will have also an output about trees removed. And well, here we will see the trees that have died due to natural causes, that die because of disturbances, and those that were removed during the management. In our case, salvage cutting. And then we have for bark beetle and for wind. And all the rest is false. Yeah, that's it with the output. So now we have the project file, and then we'll do simulation.
Have you reported by graphic clouds?